Everyone, welcome back. Okay, so last time we talked about chemistry, which was like a little bit while ago. You might have forgotten. The video I posted last week was all about transformations, and I did say, I know I said, would go more into graphs, but today we are looking and diving into more chemistry. I had a few people reach out and say they want me to talk about the periodic tables, so that's what we're doing today. We'll go more into transformations next videos somewhere down there, probably the next video that I'm posting. Okay, so today we are going to put everything we learned in the last periodic table together. We're going to look at what groups and periods are. We'll explore the types of metals on the table, from metals to non-metals and metalloids. We will explore the types of elements, non-metals, on the table: metals, non-metals, and metalloids. Plus, I'll reveal a secret weapon that will help you with any single test. This is what we call the staircase line. It's a secret, and to really help you. It's not really a secret, but it's like a thing that helps you master what is metal, what is non-metal, and what are metalloids. Okay, but first of all, before we dive in, let's review real quick. What is the atomic number of carbon? Look at the periodic table. I'll make it a little bit bigger. Look for carbon and tell me and say to yourself the atomic number. If you can pause this video if you need more time, but you have 6 seconds. The answer is 6. You can find carbon right here, and the atomic number is this. Next question. What element has the symbol Na on the periodic table? You have 6 seconds. Did you get it? It is sodium right here, number 11. Sodium. Did you forget? I know it's been a long time, but if you did forget, I'm going to show you how to find chemistry. So you go to your search browser, open up YouTube, come into my channel, go to playlist, chemistry. By the time this video is posted, there will be 2 videos in here, and this right here will be the first video on your list. Okay, let's go on. Okay, let's talk about how a periodic table is organized. As we can see, as we can see, there are a bunch of elements, all different colors too. And we'll talk about each and every single one. Let's start with groups. Groups are vertical. This is a vertical line. So that's not a vertical line. Sorry. Groups are vertical. This is a vertical. This is horizontal. I mix them up so much. Anyway, groups are vertical lines. So this entire thing is a group. You are a group. You are a group. This is a group. This is a group. It's transition metals are a little bit weird, so we'll talk about transition metals in the next video, in our next chemistry video. Let's put it that way, because yeah. Okay, so we have 18 groups. If you want to label each and every one of them, we have 18 groups. If you go through it and label, and then this is groups 3 to 12. These are the transition metals, and we are going to be ignoring them because transition metals are a whole different breed. Okay, So elements in the same group have similar properties and the same number of valence electrons. Valence electrons are the outer shell, the outermost shell when you draw your Bohr diagram. So a Bohr diagram usually works like this. It starts with this a circle, and inside we have the electrons, the proteins, and every single thing, the nucleus. It first starts with 2 dots, then draws another line, and it has 8, maximum of 8. Doesn't mean it will always have 8. And then another line, and then 8 out there, and then so on and so forth. So now, like hydrogen, if you wanted to draw hydrogen, you just draw one tiny circle and do 1 dot, because it only has 1 atomic number. The atomic numbers will help you figure out which has. Okay, so in this group, they have 1. So elements in the same group have similar properties and the same number of valence electrons. They also react in the same way. So I'm breaking down each groups and their characteristics. So the first group, this group right here, we call it the alkali metals, not to be confused with alkaline metals, alkaline earth metals. So this group are the group 1s, and they have 1 valence. They have 1 valence electrons. Like lithium, it has the first 2, 1, 2, then the 1. These groups typically lose their 1 electron because it's better for them to lose the electron than to gain 7, because they need to have 8 outer shells. So it's easier for them to lose the electrons than to gain them. So the next metals, the group 2, are called the alkaline earth metals. Can you guess how many valence electrons they have? If you said 2, you are absolutely right. Now you might be wondering, why is helium not part? Remember when I said of this group, this is how it starts with 1, 2. Well, basically, helium only has 2, which means it has a full electron. Because we can't give it another electron, because then it will need to gain 8 electrons, and no one is giving out 8 willy-nilly. So we say it has a full valence electrons. Groups 3 to 12 are the transition metals, and as I said, not this video, another video sometime next. Group 13 is called the boron group. 14 is the carbon group. 15 is the nitrogen group. 16 is the oxygen groups, or the chalcogens. These 4 groups are named after the first element. I don't know why. I would have to research that. This has 3 valence electrons. This has 4. This has 5, 6. These 2 would rather gain 3 or 2 rather than lose 5 or 6. Now this one is a different braid because it has 4. So you can either gain 4 or lose 4. And we'll talk about it later in this video. And then 13, the boron group, have 3 electrons, so they'll rather gain 5. The next group is the halogens. This is group 17, and these have 7 valence electrons. So they are looking for an electron to snatch. So they typically snatch their electrons from the alkali metals. And this is the highest reactive. This is the less reactive element because it's just looking to gain 1. And then we have the noble gases, group 18. They are not looking for any electrons. They are content. They have all the electrons they will ever need. So group 1 elements like lithium, sodium, and potassium are super reactive because they all have 1 valence electrons. As simple as that. Next up is periods. Horizontal. We have 7. 1, 2, 3, 4, 5, 6, 7. What about these two? Well, this one, we call them lanthanoids, are right over here. And then this one we call actinides, they're right over here. Again, transition metals, different breeds. Okay, so the period number tells you how many levels or shells the atom has. So when you're drawing your Bohr diagram, you say, oh, helium, it only has 1 shell. Oh, all these in period 2, they have 2 shells. Period 3 have 3 shells, and like that, and like that, and like that, and like that, and so on and so forth. I feel like periods are like the easiest ones ever. They don't have names up. Properties change gradually across a metals, so they go from reactive metals all the way down to non-metals. For example, excuse me. For example, elements in period 3 right here. Sodium, magnesium, all the way to argon, and their properties shift as you move across. Okay, let's talk about metals. First off, I am going to draw a staircase because this will help us out. Oh, that's not my pencil. Ah, my hand is not. Okay. All of these elements and aluminium are metals. Okay, so some properties of metals, they are shiny, they are solid, except from mercury, which is right here, Hg. They are good conductors of heat and electricity. They are malleable, they are ductile, and they tend to lose electrons. They lose their electrons. And they're always ionic bonds. They can't bond together. Well, the transition metals can, but then again, that's a different story. Yeah, that's why you got it. Oh, I didn't want to clean my staircase. I need to draw my staircase back. This would help out so much. I'm going to stop at that. So some examples are sodium, aluminium, iron, and gold. Non-metals are found on the upper right side of the periodic table. These are non-metals. They are dull, not shiny. They are poor conductors. They are brittle if they are solid. They are mostly gases, often gases. Not all of them are gases. There are some liquids, and they tend to gain electrons. And these can bond with each other. They can either be covalent bonds or ionic. Either they bond with other non-metals to make a covalent bond, or they bond with metals to make ionic. Some examples are oxygen, chlorine, carbon, and nitrogen. That's my nitrogen. Fun facts: even though hydrogen is on the far left, it's actually a non-metal. Did you know that? That's a very, very, very fun fact. I love that fact. It can either be a non-metal or a metal depending on whatever it pleases, because it can either lose its electron or gain its electron. So it's one of those things that it works out whatever way you want to use it. Okay, so the staircase line and the metalloids. So you're going to draw a bold staircase starting from boron all the way to astatine 80. This is zigzag staircase helps us tell the difference between metals and non-metals. Left of the staircase, metals. right of the staircase, non-metals along the staircase. So boron, silicon, arsenic, calcium, acetylene, polonium, antimony, and germanium are metalloids. Okay, metalloids. They have properties of both metals and non-metals. They are often semiconductors, they are solid but brittle, and they are used in tech like computer chip. The main ones are boron, silicon, arsenic, thallium, antimony, and acetylene. Note: aluminium touches the staircase, but it is still considered a metal. I actually don't know why. Okay, let's recap. Right after I erase this. Okay, let's recap. Metals are in the left and the center. They are shiny, they are conductive, they are malleable, and lose electrons. Non-metals are in the upper right. They are dull, they are brittle, they are poor conductors, but they gain electrons. Metalloids are mixed properties, and they are semiconductors, and they are in the staircase line. Now you can look at any element and figure out, how does it react? Is it shiny or brittle? Does it conduct electricity? Just by knowing, you can know that just by looking at it. Okay, you just unlocked the map to the whole periodic table. Well done! If this helped you, leave a like, subscribe, and drop a comment. What's your favorite group? The noble gases or the explosive alkaline metals? Let me know. Next time, we'll explore how atoms bond using their valence electrons, ionic, covalent, and metallic bonding. We might get to that, we might not. That's the transition metals. And remember, if you need to review anything, always just check my chemistry playlist.